This is Mariah Birgen for 18 years of rethinking first calculus through differential equations from Wartburg College.
Hi, everybody. I'm just gonna see if I can't reset my timer so I don't lose track of time. All right. So I'm Mariah Bergen, and I am at Wartburg College, which is a small liberal arts college in Iowa. And this is my first time at a Semiode Expo, but I've been to a bunch of their things at Math Fest. And I really want to thank the organizers for inviting me to come give this talk. I didn't always think I belonged because I'm not teaching differential equations, I'm teaching calculus, but I think this is super important for everyone. So let me tell you a little bit about why we do this. So I'm sure we all teach Calc 1 and the students memorize things. Most of the time when you're teaching a Calc 1 class, you spend your whole time talking about derivatives in the semester and maybe get to integrals. And what we found was that our students who were going to be math majors or physics majors were coming to us with credit for a Calculus 1 class. And so the students who were actually in this class were our biology majors, our pre-med students, our business students. And so they only were going to take a semester of calculus, and it didn't make any sense. Calculus was being used as a filter by those departments and not something that was useful. So we said, hey, what if we taught a class where all the applications came at the beginning and the students who needed to know how to do things using algebra could take a second semester in that? So we started with doing what we called an applied calculus class, but I think if I renamed it again, it would be modeling calculus. So it's got all sorts of questions. And what we want to do is start with the questions. I feel like I'm preaching to the choir here. And we're going to introduce differential equations by the end of week 1 so that we can get into the meat of modeling by the time the students are getting into the hard parts of their other classes. So we're going to start out saying, hey, welcome to modeling calculus. On my first day, people were talking about what they do on their first day. I tend to model what it looks like to do a SIR model or an SEIR model. Because students are coming in and out of the class. And then on week 2, I introduce the derivative, which is the approximation. So it's just the slope of the tangent line. From there, I'm going to teach them about units with derivatives. Use that to say, well, a differential equation is just an equation with derivatives in it. And then we will use slope fields and then Euler's method to solve our differential equations. So I have a little bit of a note here about computational tools, but I'm going to talk a lot more about that later. So maybe a traditional calculus class would do limits, derivatives, integrals, and applications at the end. We're going to start with questions, introduce what a differential equation is, give them numerical methods to solve that differential equations, and then get into some of the theory behind modeling. So this started out in a project that I worked with called Sensor, which is the National Science Foundation project. It's science education for new civic engagements and responsibilities. And essentially what we wanted to do is to give the students concepts so that they would remember the math longer. And that's what the research on this project showed. And again, we're looking at mostly pre-med and business students here, but also this is our only calculus class, so it's going to have anyone who doesn't have credit for a year of calculus. So we might ask the students about drug dosing. So suppose that your body releases drugs using an exponential decay model. So we would say, okay, the rate of change of drug is proportional to the amount of drug that's in your system. And what does that look like? But then from there, we will give you, okay, you don't just take a drug once, you're going to take it multiple times. So maybe you're taking a Tylenol every 8 hours. And then that allows us to introduce peaks and troughs. We get into geometric series at this point as well. So we are doing some math. It's just a different way of looking at it. This is this computer system I want to talk to you about. So this is something called Insight Maker. I just started using this one. We had been using Vensim, which is Vensim, which is free for personal and academic use. I just started using this one because it's on the computer, or it's online. It's not on the computer. And so my students with Macs don't have any problems installing it. So if you haven't used this kind of system before, what we have is a blue box, which is a stock variable. And then we have flows. So we've got an ingestion flow and a kidney flow. And then going into those flows, we have a bunch of variables that we can change. And then the drug, our differential equation is just saying that the rate of change of drug is equal to the ingestion minus the kidney. So we have the simple idea that the rate of change is just inflow minus outflow, and then all the complicated stuff happens in the flows. So what I want to talk to you about next is, okay, now we're going to make that more complicated. So suppose we go to a 2-compartment model. Maybe we take our pill and it's going to sit in our stomach for a while, and then it's going to go into our bloodstream and continue doing what it wants. So this is something the students can do in 5 minutes. They basically add a new stock variable called stomach, and then they put in a new proportionality constant K2. And we say, all right, so the drug's going to move from your stomach into your bloodstream, and then from your bloodstream out through whatever process your body wants to use. What I like about this is I ask my students, what's the rate of change of your stomach? And they're like, well, I don't know. And I'm like, okay, fine. How long does it take you to feel half full? That's going to be your half-life of your stomach. If you're a cross-country runner, maybe 30 minutes. If you're an offensive lineman, could be 4 hours, right? It's up to you. It's personalized. So I let the students think about their own space and create their own system. We do epidemic models. I'm sure you've all seen this before, but again, it's another stock variable. So you've got 3 stocks in this case, 2 flows, and then we can calculate what's happening from here. So from this point, once the students get this model working, I've heard talks already about other places you can use this. We might add an exposed stock variable. We might start thinking about vaccination. We might start thinking about a disease where just because you end up in the recovered stock doesn't mean you stay there. Maybe you become susceptible again. So the students can investigate all of that. One of the things I heard this before, someone else was getting to talk about this, is a bungee jumping model. So I also have my bungee jumpers be dolls because I don't want to break anyone's neck. And in this particular case, we have a spring model, but then the students have to modify the spring so that it only acts like a spring force when the bungee cord is extended. And so we get to talk about things like if then else statements involving a little bit more differential equations in there. So I just wanted to share the final thing we do. So this is the first semester they're in college, and we will do the drug dosing model, we'll do the bungee jumping model. There's a whole bunch of models we'll do as sort of our third model, everything from RLC circuits to launching a multi-stage rocket to, there's a really nice one I should have somebody write up for Semiode on launching a hot air balloon. But their final project is to go find a published journal article with a differential equations model in it, and then look at how they can replicate that in our system. So they are looking to see where differential equations used in the discipline they're interested in, and then creating that from there. So these are projects that my students did in their teams this winter. So published models that they replicate. This is winter. This one was fall. I want to mention the Black-Scholes model just a second. I had a student who absolutely was not interested in being in the class. He was a business major, and he didn't know why he needed to be in calculus, but he convinced his team they wanted to study the Black-Scholes model. And they're using Insight Maker, and he's sitting in the back of the room, and I can hear him saying, wait, it's got bubbles. It's doing the thing I want it to do. And so this then allowed my students to really go back and relate the math that they're learning in calculus with the math that they're going to need to know to do advanced things within their majors. So what do we use? We use slope fields so that they can visualize this. Everything is a first order differential equation. We start with Euler's method because, again, from the slope field, they can visualize how that works. We have to move to RK4, Rangakata, so I asked them to calculate RK2 and RK4 by hand. It's on the test. We use Vensim, PLE. That's the software that is free for personal and educational use. The PLE stands for Personal Learning Edition. It's quite expensive if you buy the actual thing. And then Insight Maker is the software that I've been using just for the last semester or so. So I wanted to quickly show you, I think, what that looks like. Hopefully, there we go. So this is Insight Maker. It's just insightmaker.com. But if I go to the bouncing model, you can see that we are looking at a bungee jumping or a spring force model. I've got gravity, mass, everything. The total force is feeding into acceleration, but then acceleration is the sum of the total force, or the total force divided by the mass, and everything has units. And you cannot get it to run until your units work. So that has been very educational for my students. I asked the students to tell me what the problem is. I asked them to design the model, so they have to list the variables, they have to list their assumptions. If they make simplifying assumptions, they have to list that. I need their variables to have units, and I need all of the units to make sense so that when they have a differential equation, the units on the left side of the equal sign have to equal the limits on the right side of the equal sign, and everything has to have the same units. This is a real struggle for my students. I think it's highly educational. And then they create a model solution. Ours is numerical. It's not an analytical solution. But then what that allows us to do is study things which are nonlinear or things that don't have exact solutions, like you might in a more advanced differential equations class. And then they have to look at their results and their conclusions and go back to the original problem and see if things make sense. Which is why when we do the spring modeling, they realize that something is wrong because Euler's method has an exponential increase in their error term. So their spring doesn't do what they think it's going to do. Each assignment, I'm asking them, show me what this looks like, tell me what their assumptions are. And so I have been doing this since 2008. The students are really engaged with their final projects, not so much their first one, but they have to learn why they're doing it. They're learning about programming and all the kinds of things that might go into a function. Yes, they're not as good at their algebra skills, but they're not coming to me with strong algebra skills. I think what we're really getting is the why of calculus and the confidence that they could read a journal article from their discipline and figure out what all the variables and units mean and have it make sense. So a couple of things that you might want to do, I'm preaching to the choir here, but I would say that I haven't seen people using a lot of software. So Vensim, PLE, and Insight Maker are excellent tools. And I'm looking forward to going through the Simio library to find more things that we can use. And then it's all about iteration. So start with a simple model. I won't let the students turn in a model that doesn't work, but they will get a lot of credit for a simple model that does work. And then they tell me what they would do to make that model better. So if you want any of the things that I have talked about, you can just go to this URL. And I think I can put that in the chat. And so this is just a folder where I put together some of the things that I use with students. The book is just PDF. You can look in there and see what we're doing, and certainly contact me if you have any interest in more of this for that earlier than your differential equations class courses. So get back to the PowerPoint. There we go. Oh, we won't talk about challenges. We're going to keep this one happy. So give it a shot. Try this with your calculus students. I think Jason, who I heard earlier, would agree with me on this one. And then nobody asks me when they have to take, why they have to take calculus. I have students who are taking calculus for fun. And at this point, I have my pre-med students taking calculus their last year because they want to learn more about how to use the math they know in their med school. So thank you very much. And I think I can stop at this point.